This lesson is on the mean or expected value of a discrete probability distribution. So just before we launch into the questions, we better have a bit of background. So mean we're already familiar with, meaning the average. You add them up and divide by how many scores there are, and you've probably already seen this X bar symbol before. That's technically the sample mean. If you actually ask everyone in a population and you get the mean of the whole lot, we give it the symbol mu. Now, in a discrete probability distribution, we actually use that mu symbol for the mean. So this is what this means, the expected value of the discrete random variable x. That's what we're calling the mean. We're also giving the symbol mu. So these three things really are exactly the same. So how are these linked, by the way? How's the mean of a sample linked to the mean of a population? Well, I guess this makes a fair bit of sense. How they're linked is that the bigger your sample is, the closer, and this makes a lot of sense of course, the closer the sample mean gets to the population mean. So that's something that's actually in the syllabus. Okay, now, so again, we talked about how we're actually talking about with the probability distribution, the expected value is we're giving the symbol mu, so the population mean. But how do you work it out from the table? That's really the question. That's what this lesson is really all about. How do you work it out from a table? Okay, so we'll go over to an example over here. And well, actually, I will write it here. How you do it is you actually add up the sum. You add up the scores multiplied by the probability. So in other words, you multiply the score or the result by the probability and you add them up. So let's keep that in mind for all of these questions. These are from the textbook. So example 10, page 675, it says basically just find the expected value of this. So the expected value, remember x, capital X is what are we going to get? The expected value is the probabilities times the result for each one. Of course, it doesn't matter which way around you multiply these. You multiply them together and add them all up. It's the sum of all of those. So it's the probability times the result for the first one, plus the probability times the result, plus the probability times the result, plus the probability times the result, plus the probability of the last thing times the result. And you just add them up. So I'm just going to use the results because I did them earlier. Hopefully this is 3.2. And of course you can give your the old common sense feel. Does that look about right? Yeah, it looks about right. We're getting between 1, 2, 3, 4 and 5. We're getting those numbers. So it has to be somewhere in the middle of those. That's 3.2. Next question. Bethany tosses 2 coins. It's a game. She's playing a gambling game. If she gets 2 heads, she wins $10. If she gets 2 tails, she wins $5. But if she gets 1 of each, because there's only 3 results, she gets no dollars. So the question is, find the expected value of playing this game. Of course, every time you get one of these, and when you're doing the homework as well, you need to work on a table first. You need a probability distribution table. So how many things can we have here? We can have number of heads. Oh, well, actually, what we'll put in the result. The probability of winning $10, probability of winning $5, this is going to go on the bottom, and the probability of winning 0 is what's going to be the 3 things. There's only 3 results we can get. Now, what are the probabilities? It's about heads and tails, the number of heads. So we've got head, tail, head. This is to help us get the probabilities. Head, tail, head, tail. So what's probability of winning $10? That means getting 2 heads. That's 1 over 4. Probability of getting 2 tails. That's also 1 over 4. And the probability of getting 1 of each is 2 ways of getting that. So 2 over 4 or 1/2. You can have either. So this is what you should do every time. Get a table with the values that you're going to end up with, the discrete random variables, and the probabilities of each one. So now we're doing the expected value. It's the probability multiplied by the result, or the result times the probability. Probability times the result. Probability times the result, although that's not going to give us any contributions at all. So that's going to be quarter of 10, so that's $2.50. This is going to give us 5 quarters, so 1.25. This is 0, so it's $3.75. So that's the expected result of playing this game. All right, now there's a part 2 to this question. If it costs $5 to play, what happens in the long term? Well, clearly, if it costs $5 to play, you're going to be, and you're winning on average $3.75, you're going to be losing money. You will lose. I mean, quite a lot actually, if you end up playing a lot. But you play it once, you're going to lose $1.25. So that's what we do with some of these numbers. Okay, we'll look at one more example. This is a very similar question in a way. You've got a table. Remember, if you don't have a table, you make the table. The first thing you do is make the probability distribution table. And this one says, find A and B if the expected value is 2. So we're given the mean, we're given the expected value is 2. And find A and B. All right, well, let's just do exactly what we did before. The expected value is the probabilities times the score, plus the probability times the score, plus the probability times the score, plus the probability times the score. So this is going to be A plus B, 2B plus 0.6 plus 0.4. And that's when you've got to stop and think, what does this equal? So this is going to equal 2 because we're given that this is 2. So we're going to end up with the pair of simultaneous equations. So we're going to get A plus 2B equals, that's 1, so that equals 1. There's one simultaneous equation. Why are we going to get simultaneous equations? Because we also know that these add up to 1. So A, we do it over here, A plus B plus 0.2 plus 0.1 has got to equal 1. A plus B has got to equal 0, what is this, 0.3, 0.7. And we just solve them simultaneously. I'm going to call that 2 and this 1. I'm going to, what am I going to do? I'm going to minus 1 from the other. I'm going to go 1, take away 2, just because it'll get rid of the A's. So I'm going to go 1 minus 0.7 is 0.3. A minus A is 0. 2B minus B is B. So B equals 0.3 straight away. Sub that into 2. Doesn't matter which one you put it into. You're going to get A plus 0.3 equals 0.7, so A equals 0.4. So we've got a value of A and a value of B, and that'll work for both of them. So in class or at home, you can work on these ones. Remember the first step every time, because there's really 2 steps to these. The first step is write a table. Get a table like this first. Get a probability distribution table. And then the second step is do the expected value with the probabilities times the values all added up. Good luck.